Hello everyone, this is Matteo from Starway Design. In the previous video, I had described the motivation and objectives of this video series. In this video, I'm going to show you how to use version control for AMD Vivado and Petalinux projects. I'm going to use Git, but you can use SVN or other version control tools. Let's begin. A typical Vivado FPGA project has a block design as a top level with an automatically generated managed wrapper. It has a mix of Vivado and custom IP cores. I used the auto context flow for synthesis since it reduced the build time by caching IP cores that have been modified or updated. When I was researching how to better integrate Vivado with source version control, I defined the following requirements. The block design is the primary source to recreate the design, IP cores configuration, wiring, etc. The top-level wrapper HDL file shouldn't be under version control, since it can be recreated from the block design. Minimum tickle scripts coding for each project. It should be easy to save changes made in the Vivado user interface, in example implementation settings. Use the project-based auto-context flow to reduce build time. Continuous integration friendly. Vivado can do most of the heavy lifting by generating a tickle script to recreate the project using the command write_project_tickle. By default, it embeds the block design in the tickle script, but it can be configured to use an existing block design file. There is only one issue. The top-level wrapper HDL file is part of the source set and is not generated automatically, but I have created a simple script to get around it. You can download a template folder structure with the scripts from GitHub. Let's check out the template and see what's inside. Inside the FPGA directory, there is a BD directory that is where we're going to save the block design file. Vivado is where the temporary Vivado project files are going to be stored and its content is not under version control. The FPGA scripts folder contains a couple of tickle scripts. We're going to use create_project_tickle. It calls the write_project_tickle command with the correct parameters for this folder structure, stores the generated file in the scripts folder, and modifies to regenerate the top-level wrapper file when the script is executed. Let's create a new Git repository and add the current files to it. For this example, I'm going to use a cloud-based GitHub installation, but it could be hosted locally. Let's create a new repo using the web interface and clone it. Copy the files from the template, add all the files to the Git repo and do an initial commit. Now let's create a Vivado project called DevOps example. Use Vivado as a target directory and make sure create new directory is not selected. For example, we can create a project targeting a Z board which is based on the Zinc 7000 SoC. You might need to download the board files. We then create the block design with the LEDs and buttons. The block design has the same name as the project and it is saved in the BD directory. Generate the top-level wrapper and let Vivado manage it. Build the project to make sure everything is fine. Now, from the Vivado tickle console, we can run create_project_tickle to create a script that will regenerate the Vivado project. Make sure you are inside the FPGA directory. We can now exit Vivado and add two files to the Git repo, the block design file and the script that was generated when we executed create_project_tickle. All the other files can be regenerated so they don't need to be under version control. To show how to recreate the project, we can delete all the files that aren't under version control. Now we execute the script recreate_project. Now we have recreated a project with the minimum number of source code files, but we can still use the Vivado user interface. Couple of notes on the scripts. The various scripts assume a directory tree as described earlier. Before launching recreate_project, the Vivado folder must be empty. This is by design, since it avoids overwriting the project by mistake. The file recreate_project must be under source version control. create_project_tcl must be called every time you change settings in Vivado. In the sample project, you can see how git ignore files can be used to avoid adding files generated by Vivado to the source version control. What about PetaLinux? It is a bit easier and doesn't require any scripting. Let's build the bitstream of the example project and export the design with the bitstream. Now, let's create a simple PetaLinux project using the design we have just exported. Use the default options for now. Let's add the PetaLinux project to the source version control. Note that PetaLinux automatically creates the git ignore file. Build the PetaLinux image. Now let's show that it's possible to rebuild the project. And create the deployment files. Let's copy the generated files to the SD card. Insert the SD card and turn on the board. Use PicoCom to view the console. That's all for this video. In the next video, I'm going to show you how to integrate Vivado and PetaLinux with GitLab continuous integration. If you enjoyed the video, please leave a comment, click on the like button and subscribe to the channel.